what is meant by projectile motion? Okay, we already learned the rectilinear motion, okay, circular motion. Okay, now we are studying a new point, that is projectile motion. Okay, now see here, this is the horizontal surface. Okay, now see here, an object is thrown in air with initial velocity in any direction. Okay, suppose I throw an object in any direction, okay, in any direction with initial velocity. Okay, now this initial velocity making an angle with the horizontal surface. Okay, is making and some angle with the horizontal surface. Okay, now see, suppose this is the ground surface. Okay, I am standing here. Okay, and my friend is sitting at position B and I am standing at position A. Okay, so I throw a ball towards my friend. Okay, suppose I throw a ball towards my friend. So this object or that ball is moving in any direction with initial velocity u. Okay, this object or that initial velocity makes an angle theta with the horizontal surface. Okay, and this object is moving in this direction. Okay, so this object is moving under gravity. This object is moving under gravity. Okay, so such type of motion is known as projectile motion. Okay, so what is meant by projectile motion? An object is thrown. An object is thrown in air with initial velocity in any direction Okay, so this making an angle theta with the horizontal surface. So making an angle with the horizontal, making an angle with horizontal, and moving freely okay, under the presence of gravity. Okay, such motion is known as projectile motion. Okay, such motion is known as projectile motion. Okay, now see here, this is the horizontal surface. I am standing at position A and my friend is at position B. Suppose I throw a ball initial velocity u. Okay, this initial velocity makes an angle theta with the horizontal surface. Okay, and this object is moving freely, okay, under the presence of gravity. Okay, such motion is known as projectile motion. Okay, now what is meant by now next point, that is velocity of projection. Velocity of projection. Okay, so what is called as velocity of projection? The velocity with which that object is projected. Okay, that velocity is known as velocity of projection. Okay, so what is by velocity of projection? Okay, so the velocity with which the velocity with which that object is projected, such velocity is called as velocity of projection. Now next, this theta is known as angle of projection. Okay, this theta is known as angle of projection. Okay, so what is by angle of projection? The angle made by the velocity of projection with the horizontal surface. Okay, the angle made by velocity of projection with the horizontal surface, this angle is known as angle of projection. Okay, an angle made by velocity of projection with horizontal surface is called angle of projection. Okay, so this is called as angle of projection. Now the vertical maximum distance. Now see here, the vertical maximum distance. This distance is known as height. Maximum height. Okay, and if we throw a ball from position A towards the position B, that means that object covers the distance. So that distance is known as range. We will discuss this range and maximum height. Okay, so what is by projectile motion? An object is thrown in air with initial velocity in any direction, making an angle with the horizontal and moving freely under the presence of gravity is known as projectile motion. Okay, and next one, the velocity. Next one, that is velocity of projection. The velocity with which that object is projected is called velocity of projection. And the next point, that is angle of projection. the angle made by the velocity of projection with the horizontal surface, that angle is known as angle of projection. Okay. Now there are some assumptions for the projectile motion. Okay. There are some assumptions for projectile motion. Okay. So first one, for the assumption for the projectile motion, that is first one, that is air resistance is negligible, that is equal to 0. Okay. Now next one, the acceleration due to gravity is constant. Acceleration due to gravity is constant. Okay. Throughout the motion. That means here, if that object is at here, okay, then the acceleration due to gravity is at any position, okay, is constant throughout the motion. Okay. And the effect of rotation of the earth, third one, that is effect of rotation of earth, effect of rotation of the earth on the projectile is negligible. Okay, these are assumptions. Okay, now the velocity of the projection. Now the velocity of projection is resolved into two components. Okay, that means along x-axis and along y-axis. Okay, this velocity of projection can be resolved into two components, that is along x-axis and along y-axis. Now see here, if we throw that object, that means that object is here, so it covers some distance along y-axis and also it covers a distance along x-axis. Okay. Similarly, that object is here. Now then see here, that object covers some distance along y-axis and similarly that object covers some distance along x-axis. Okay. That means that velocity of projection can be resolved into two components, that is along x-axis and along y-axis. Okay. So along x-axis and along y-axis. Okay. Now see here, that object is thrown from point A towards the point B. Okay, with velocity u. Okay, so we know that the velocity of projection can be resolved into two components. Okay, suppose along x-axis, that is ux, and along y-axis, that is uy. Okay, so according to this is right angle triangle, so we can calculate ux. Okay, so adjacent side is ux upon hypotenuse. Hypotenuse means initial velocity, that is u. So therefore ux is equal to u cos theta. That means initial velocity along x-axis is u cos theta. That means ux is equal to u cos theta. Okay. So this is the rectangle. So this one is ui. So this also ui. So ui is the front side of theta. So we can take the ratio of sin theta. So sin theta is equal to front side upon hypo. Okay. So front side is ui. Front side is ui upon hypotenuse is u. So from this we get ui is equal to u sin theta. Okay. So first calling equation number 1, equation number 2. That means ui is the initial velocity along y-axis. So ui is equal to u sin theta. Okay. So now we will discuss along x-axis and along y-axis. What are the difference? Okay. Now see here, along x direction and along y direction. Okay. Now see here, the initial velocity along x direction is ux is equal to u cos theta. Similarly, initial velocity along y-axis is uy is equal to u sin theta. Uy is equal to u sin theta. Okay. Now see here, the acceleration. Now we will find the acceleration along x-axis and acceleration along y-axis. Okay. If the particle is moving along x-axis, then the velocity of that particle is constant. Okay. Now we know that acceleration means change in velocity. Change in velocity upon time. Okay. So change in velocity, but velocity is constant along x-axis. That means the acceleration along x-axis is 0. Okay. That means the acceleration is along x-axis is 0. Okay. Why 0? Because velocity along x-axis is constant. So acceleration means change in velocity. So velocity is constant. So acceleration is equal to 0. Okay. Now see here, if that object is moving in this direction. Okay. Now see here, if that object is moving along y direction, then there is acceleration is provided. That acceleration means acceleration due to gravity. So this acceleration due to gravity is moving in downward direction. Okay, is moving in downward direction. That means the acceleration along y-axis. That means the acceleration along y-axis is minus g. Why minus g? Because object this position, okay, then its velocity becomes 2 meter per second. At this position the velocity becomes 1 meter per second, and at this position the velocity along y-axis becomes 0, okay, and see here the velocity along x-axis is same as it is initial position. That means velocity along x-axis is same, it is constant, okay, and the velocity along y-axis it is first decreases, then at the highest point it becomes 0, and again it increases, okay. That means velocity along y-axis first decreases, then 0 at highest point, okay, and last it is increases. Next हम परत ऐका that initial velocity is u. It can be resolved into two vertical components along x-axis, along y-axis, okay. If that object is moving in this path, okay, along x direction, its velocity is same. Its velocity is same along x-axis. If that object velocity along y-axis, firstly it gets increases, at the highest point it is decreases. That means it is equal to 0. Why? If the velocity is highest, then object is going to upward side, okay. So here the velocity is 0. Then this along x-axis the velocity is same, but along y-axis the velocity is slowly increases, okay. So these are the difference. Initial velocity along x-axis is u cos theta, initial velocity along y-axis is u sin theta. Acceleration along x-axis is 0. Why 0? Because velocity along x-axis is constant or same, and here acceleration along y-axis it is minus g. That means minus of acceleration due to gravity, okay. And the velocity along y-axis, firstly it decreases, at highest point it becomes 0, then it increases, okay. These are the most important, okay. On the basis of these we will find the new formulas, that is time of flight, time of ascent, time of descent, maximum height and range, okay. Now next point, that is time of flight. We will find the time of flight, okay. Now see a particle is thrown from A to C with initial velocity u, okay. This velocity can be resolved into two components along x-axis and along y-axis. So ux is equal to u cos theta. This is the horizontal component. U cos theta is also known as a horizontal component of initial velocity, and uy is equal to u sin theta. This is the vertical component along y-axis, okay, where h is the maximum vertical distance. This is also known as a height, maximum height, and the distance between A to C, this is also known as a range, okay. Now see here, that object covers a path from A to B, it requires time t, consider a motion, along y-axis. Consider a motion along y-axis. Okay, from A to B, from A to B. Okay, now see, the particle or that motion is along y-axis. Okay, now the initial velocity along y-axis is, initial velocity means u1 is equal to u sin theta. This is the initial velocity along y-axis. Okay, so that means uy is equal to u sin theta. This is the initial velocity along y-axis. Now acceleration along y-axis, we already see acceleration is here along y-axis. It can be moving in downward direction. That means acceleration ay along y-axis is minus g. Okay, minus of acceleration due to gravity. Okay, now the final velocity. Now the final velocity from A to B. Okay, the particle is at B, so the final velocity is 0. Okay, along y-axis. So Vy is equal to 0. This is the final velocity. And to cover the path from A to B, it requires time t. That means time is equal to t. Okay, so now we using the first kinematic equation. Okay, so first kinematic equation, v is equal to u plus at. Okay, so substituting this value in this equation, final velocity is 0, initial velocity is u sin theta, acceleration along y-axis is minus g, and time period is equal to t. So we get 0 is equal to initial velocity along y-axis is u sin theta plus acceleration along y-axis is minus g into t. Okay, so we get u sin theta is equal to g into t. Okay, therefore t is equal to u sin theta upon g. Okay, now we want to find the time of flight. That means the time required to cover a path from A to C. Okay, so total time, so we say that capital T, that is time of flight, is equal to t plus t, is equal to 2t. So we get 2u sin theta upon g. This is the formula for time of flight. This is the formula for time of flight. Okay, this can be calculated by another way. It is considered that motion is along y-axis, but we consider the path from A to C. Okay, A to C. Okay, so now see here, the initial velocity along y-axis is u sin theta, acceleration along y-axis is minus g. Okay, time, so time is t plus t, that is capital T. Okay, and the displacement along y-axis is 0. Why 0? Because that particle is moving from A to C. So shorten distance between A to C. So AC is along x-axis. So the displacement is 0 along y-axis. So we can write initial velocity along y-axis is u sin equation. So we get S is equal to ut plus half 8t square. Okay, so substituting the value, displacement along y-axis is 0. So 0 is equal to initial velocity along y-axis, that is u sin theta into t plus half into acceleration due to gravity. Okay, so acceleration due to gravity is minus g into t square. So we get u sin theta into t is equal to half g t square. T get cancelled. So we get u sin theta is equal to half g into t. Okay, so t is equal to 2u sin theta upon g. This is the time of flight. Okay, both the formulas are same. Here we are calculating from the path A to B, and here from A to C. Here we use first kinematic equation, V is equal to u plus 18. Here we using the second kinematic equation, S is equal to u plus, so S is equal to ut plus half a t square. Okay. Okay. Now see here, the time required to cover a path from A to B is known as time of ascent. Okay, and to find, the time required to cover path from B to C, this time is known as time of descent. Okay, so we are calculating here time of ascent. Okay, from A to B. Now we want to find the time of descent. Okay, so now see here, time of descent is equal to time of flight minus time of ascent. That means TD is equal to time of flight minus TA. So substituting this value, time of flight, that is 2u sin theta upon g minus time of ascent, u sin theta upon g, u sin theta upon g. So we get u sin theta upon g. So from this we can conclude that is time of descent is equal to time of ascent. Okay, time of descent is equal to time of ascent. Okay, now next point, maximum height. Okay, now see here, similarly let us consider motion along y-axis, motion along y-axis from A to B. Okay, now see here, what is my maximum height? The maximum vertical distance, this distance is known as height. Okay, so now we want to find the height. Okay, now see, first of all, the initial velocity along y-axis, that is uy is equal to u sin theta. Okay, now u sin theta. Now next one, the final velocity along y-axis, that is vy is equal to 0. Acceleration along y y-axis is minus g. Okay, and the displacement along y-axis from A to B, displacement along A to B along y-axis means here h is the displacement along y-axis. Okay, so now we are using kinematic equation v square is equal to u square plus 2as. Okay, 2as. Now substituting the value, final velocity 0, initial velocity u sin theta plus 2 into minus g into displacement h. So we get u sin theta is equal to 0 is equal to u sin theta minus 2gh. Okay, so u sin theta is equal to 2gh. Therefore h is equal to u sin theta divided by 2g. H is equal to square is here now. So we get 0 is equal to u square sin square theta plus minus 2gh. Okay, now u square sin square theta is equal to 2gh. Okay, so h is equal to u square sin square theta upon 2g. This is the maximum height. This is the maximum height. Okay, understand? Now next point, horizontal range. Okay, now let us consider a motion. Consider a motion along x-axis. This motion is along x-axis. Now see here, the initial velocity along x-axis is ux is equal to u cos theta. Okay, now acceleration along x-axis, velocity is constant along x-axis, then the acceleration along x-axis is 0. Okay, so acceleration along x-axis is 0. Displacement along x-axis is r. Displacement along x-axis is r. Okay, and the time period from A to C, that is t is equal to capital T, time of flight. Okay, so these are the initial velocity along x-axis u cos theta. Acceleration along x-axis is 0. Why? Because the velocity is constant at everywhere along x-axis. Displacement along x-axis is r, and the time period is t is equal to capital T, time of flight. Okay, so now we using the second kinematic equation, that is s is equal to ut plus half a t square. So displacement r is equal to initial velocity u cos theta into t, means plus half into acceleration along x-axis is 0 into t square, where t is the time of flight. So we know that the formula for time of flight. So we get t is equal to 2u sin theta upon g. sine 2 theta upon g. Okay, these are the basic formulas. First formula, time of flight. Time of flight is equal to 2u sine theta upon g. Horizontal range or maximum maximum height h is equal to u square sine square theta upon 2g, and horizontal range r is equal to u square sine 2 theta upon g. Okay. Okay, now we will take a numerical. A ball is thrown with 5 meter per second at an angle 37 degrees Celsius. Find time of flight, maximum height and horizontal range. The value of acceleration due to gravity is 10 meter per second. Okay, now we know that the formula for time of flight, that is t is equal to 2u sin theta upon g. 2u sin theta upon g. So substitute the values. 2 into initial velocity is 5 meter per second into sin 37 degrees Celsius divided by g is 10. Okay, so this get cancel. Now sin 37 degrees Celsius. Okay, how we find the sin 37 degrees Celsius? Okay, so now see here, remember this. If theta is equal to 37 degrees Celsius, then this triangle is most important. 3, 4, 5. Okay, 3, 4, 5. So from this we can calculate sin theta. Sin theta is equal to front side upon hypotenuse. That is sin 37 is equal to 3 by 5. Okay, and also remember that if theta is equal to 53 degrees Celsius, then hypotenuse is same, but sides are changed. So sin 53 is equal to 4 by 5. These triangles are most important and very useful for solving the numericals. Okay, so sin 37 is 3 by 5. Okay, so we get 0.6. This is the time of flight. Okay, 0.6 second. Next one, that is maximum height. Okay, or maximum height. So maximum height, the formula for the maximum height h is equal to, that is u square sin square theta upon 2g. U square sin square theta upon 2g. So substitute the value. U is 5 into 5 into sin square theta. That means sin 37. Sin 37 means 3 by 5 into 3 by 5 divided by 2 into 10. Okay, so we get 5 get cancel. 3 3s are 9 upon 20. Okay, so we will find that answer. So next one, that is range, horizontal range. R is equal to u square sin 2 theta upon g. Okay, so we know that sin 2 theta is equal to 2 sin theta cos theta. So u square into 2 sin theta into cos theta divided by g. So we get u 5 into 5 into 2 into sin theta. Sin theta is 3 upon 5. Triangle remind 3, 4, 5. Theta 37. So sin theta is equal to front side upon hypotenuse into cos theta adjacent side upon hypotenuse divided by g. So 5 are solved by using the formulas. Okay, thank you.